Assalamualaikum and good morning to every panel. So this is the structural key plan of the Bangi showroom. So from this key plan, we can find out that it has 5 story of building, which is the first one is the upper ground floor, lower ground floor, first floor, second floor, and the third floor. So from the key plan, we can also see the building from the side view. This is important to find the height of every story. So the side view can be divided into section AA and section BB. So finally, from the key plan, we can identify the elevation, which is elevation 1, elevation 2, elevation 3, and elevation 4. So without any delay, let's go to the earthwork design of this building.
For earthwork design, first we need to draw the boundary line for the site and the grid line and label it with numbers and letter. A, B and 1, 2 box. Next, we need to find the existing level at every corner of the box AB 1, 2. So next, we need to calculate the average height for the box AB12. So we total up all the value and divide by 4 to determine the average height. Next, we need to calculate the proposed level, which the formula is total platform level minus average height divided by 4. So for early assumption, we choose 34.7 for our platform level and minus it with the average height that we calculated previously and divide by 4. So we got negative 3.04x. The negative sign means that the earth need to be filled. To calculate the volume, which the formula is proposed level multiplied by area. For the area, we are using scale 1 cm to 15 meters. So means that the area is 15 multiplied by 15. That's why we got 225. And we multiply it with negative 3.048, which is the proposed level with at the previous calculation, and we got negative 685.8 meters square, which is the volume need to be filled at the location. Calculate the other boxes in the grid line by using Excel. Next, total up all the volume of cut and fill for all boxes. After that, we need to calculate the percentage difference, which is the formula is modulus total volume cut minus volume fill divided by volume cut plus volume fill divided by 2 times by 100%. Next, by using the value we got from Excel, we calculate the percentage difference. So the percentage difference we got for this design is 5.77%, which lies between 0 to 10%. Means that the platform level proposed is acceptable.
Hi, proceed to design of beam simply supported. Firstly, we need to determine the design action. After that, we will proceed to finding the area of steel to determine size of reinforcement steel to be used. Then we will check for shear to identify the size of link to be used, and then we will proceed to checking for deflection, and lastly we will do for detailing. The beam size that we use is 225mm times 450 mm. Okay, then the material strength and the parameter that we use is as follows. Then we can proceed to loading, which is here we got permanent load and live load. The permanent load here are beam substrate, slab and brick wall. and the live load is actually at the slab, which is here 1.35 plus 1.5, 1.35 GK plus 1.5 QK. The QK is the live load, which is there 2.0. Then we total up the value, we got 35.39 kN per meter, which is the total design action. Then we'll proceed to find the shear VED and moment MED. Then we go to find the effective depth, which is 450 minus with cover minus with link size and minus with bar size over 2. Then we can proceed to find the K value and Z value. Here K value we got lesser than 0.167, so we didn't need to design for compression. After finding the K and Z value, we will proceed to AS required to find the AS required, which is here we got 240.23 mm squared. Then we will use table to get the AS provided, and then we can find the suitable reinforcement steel to be used, which is here we got 4H10. Then we will proceed to shearing. We will do the same method. We find the ASW over S required, which is here we got 0.197 mm. Then we will use table to get the ASWS provided. Then we can find the suitable link size for the beam, which is here we got H8 300 mm center to center. Okay, then we proceed to deflection. Firstly, we need to find the P0 and P, then compare. If we got P lesser than P0, we will use this formula, which we got 46.25. Then we will proceed to find the L over D allowable and actual. Here we got the actual is lower than allowable, so it is okay. The beam detailing is as follows.
For estimation part for this process, we're going to start with preliminaries activities. Preliminaries activities is the activity or works that need to be done before actual construction works in a project. So these are all the works or activities that included in preliminaries. One of the example is sample and test, or setting out, inspection of site, foreman and assistants. So the unit for all of these activities is lump sum, and these are all the rate according to JKR specifications, and these are all the amounts. So the total estimation for preliminaries activities in this project is 41,000 ringgit. So the total estimated estimation cost for all activities involved in this project is at 162,163 ringgit and 40 cents. So next. So this is the summary for estimated amount for all activities that need to be done in this project. So these are all the items, and this specific amount for all of these works, and the estimation of total cost is at 162,237 ringgit and 93 cents. So this table shows the project management for this project. The wastage is the importance of a task when it comes to contributes to overall task progress. So the project will be started on August 2020 and expected to be fully completed on April 2021. So down here is the physical S curve for this project. As you can see, on August 2020 until December 2020, the progress for this project is expected to be fast and slow down a bit, and fully completed on April 2021. So that's all from me. Thank you.
So, for any kind of building, design analysis must be made to check if the structure fail or not. After completion of design, taking off must be made to identify the quantity that is required. Also, finally, bill of quantities or BQ also has been very important to estimate the total cost of construction.